The next chapter is electrons and photons. Now, first of all, the important formulas. The basic formula for kinetic energy, that is the maximum kinetic energy, is half m v max square, which is equals to electron volt. E is equals to h nu, which is hc by lambda. V max square can be given as 2 into w naught lambda naught minus lambda upon me lambda, where w is your work function. Alright. Conditions for photo emission. Conditions for photo emission. Nu should be greater than nu naught and lambda should be less than lambda naught. Now these are both the threshold frequency and threshold wavelength. The next important formula is momentum of photon, that is momentum of photon. P is equals to E upon C, which is h nu by C, h by lambda. So these are the important formulas. Now the important synopsis. Light behaves as waves at low frequency. Light behaves as waves at low frequency, and it behaves as particles at high frequency. Now the next synopsis. When light behaves as particles, when light behaves as particles, the particle of light is called photon. Photoelectric effect is based on law of conservation of energy. The work function that is W naught varies from metal to metal. The effect of a photon on the retina remains for 1/10th second. The emitter is a metal plate coated with a photosensitive material. Photosensitive material. So emitter is a metal plate coated with a photosensitive material. Now, when the temperature increases, work function decreases. When temperature increases, work function decreases. The basic formula for Einstein's equation. Basic formula for Einstein's equation is h nu is equals to w naught plus half m b max square. Photon has 0 rest mass. Formula for wavelength is lambda is equals to h by mv. It has a 0 rest mass and the length is lambda is equals to h by mv. Now, the maximum kinetic energy emitted by a photoelectron, kinetic energy max, is equals to product of charge into stopping potential. So that's it with electrons and photons. The next chapter, which is very very important with CET point of view, is atoms, molecules and nuclei, AMN. Let us discuss the important formulas. Angular momentum is given as mvr, which is nh upon 2 pi. Energy difference between two successive energy levels, that is delta E, is E2 minus E1, which is h nu. Energy of nth Bohr's orbit, we all know this formula, E is to 4m upon 8 epsilon naught square n square h square. It can be given as minus rch upon n square, which is 13.6 upon n square electron volt. Now we have relation between kinetic energy and potential energy. Total energy is equals to potential energy plus kinetic energy. We can also say potential energy is equals to 2 into total energy. Potential energy is equals to minus 2 into kinetic energy, and kinetic energy is equals to minus into total energy. Acceleration of electron. The acceleration of electron A is equals to pi m e raised to 6 upon 4 epsilon naught cube h raised to 4 into 1 upon n raised to 4. Then we have wave number, which is one of the most important formulas. A wave number of radiation, that is nu bar is equals to 1 by lambda, which can be given as r into 1 upon n1 square minus 1 upon n2 square. The next is energy, E is equals to h nu upon E, which is energy of photons, hc upon E lambda in electron volts. Please remember mass defect. delta m is equals to zmp plus n into mn minus m, and your n is equals to a minus z. We have radius of nucleus. Radius of nucleus r is equals to r naught a raised to 1 by 3. Now half-life period is given as t half is equals to 0.693 upon lambda. Mean life tau is equals to 1 by lambda. Now the synopsis. Now Bohr's model of atom is only applicable for hydrogen atom. Please remember, it's only applicable for hydrogen atom. When an electron de-excites to a lower state, a photon is emitted. When an electron absorbs a photon, and if it is excited to a higher energy level. Yes. Atomic clock may produce an error of approximately 1 second in 30 years. Chromium and neon atom have lifetime of the order of 10 raised to minus 3 seconds. The basic formula for wave number as discussed prior to this, 1 by lambda is equals to r upon p square minus 1 upon n square, where p is your ground state. That's it in this session. The next session will discuss about the MCQs. Alright, wave theory of light MCQ. We have the question here. Velocity of light in diamond is 5/12 of that in air. So I would say VD is 5/12 into C. That is where C is velocity of light in air. Velocity of light in water is 3/4 of that of air. So VW is 3/4 of C. The angle of incidence of ray of light traveling from water to diamond. So I has been required. R is 30 degrees. Now, solution. We know VD is equals to 5/12 C and VW is equals to 3/4 C. Therefore, VD by C is equals to 5/12 and VW by C is equals to 3/4. So VD by C is 5/12, therefore C by VD will be 12/5. Here C upon VW will be 4/3. This will be nothing but mu D, which is 12/5, which will be 2 point something, but we'll keep it in fraction because that will easier or simplify our calculation. This will become mu W, which is 4/3. Now, therefore, refractive index of diamond with respect to water is mu D upon mu W. That means 12/5 into 3/4. 4 ones are 3s are. This is 9/5. So this is W mu D is equals to 9/5. Now we can say that W mu D is sin I upon sin R. So sin I is equals to 9/5 into sin 30. So that is equals to 9/5 into half, that is 9/10. Therefore I will be sine inverse of this, option A. The 6563 line emitted by hydrogen atom in a star is found to be redshifted by 5 angstrom unit. The speed with which the star is receding from the earth is, okay, Whenever a question arises on spectral line of stars, we straight away use Doppler shift. So delta lambda upon lambda is equals to minus plus V by C. I'll use magnitude form. So delta lambda by lambda is equals to V upon C. Therefore, V is demanded. So delta lambda upon lambda into C is equals to V. Delta lambda is given as 5, while the original wavelength is 6563 into 3 into 10 raised to 8 meter per second. So this after simplification will become 2.29 into 10 raised to 5 meter per second. Option D. Next question. The ratio velocity of light rays of wavelength 4000 angstrom and 8000 angstrom unit in vacuum. Okay, so the hint is vacuum. In a vacuum, the velocity remains the same. Therefore, V1 is to V2 will be 1 is to 1. Option C. The next question. When light waves travel from one transparent medium into another, the characteristics which undergo changes are frequency and wavelength, frequency and amplitude, velocity and wavelength, velocity and frequency. Now, even if the medium changes, frequency will never change. That is because frequency depends on the source and not the medium. Hence, the options where frequency has been included will be rejected, and the option where frequency is not been included, that is velocity and wavelength, and yes, velocity and wavelength will change with respect to the medium. Next chapter, interference and diffraction. Now, two coherent monochromatic light beams of intensities I and 4I are superposed. The maximum and minimum possible intensities in the resulting beam are. Now, this is one of the most famous questions that have come in multiple competitive examinations. So, we need maximum and minimum intensity. The basic formula for I max is root of I1 plus root of I2 the whole square. Now, I have I1 as I and I2 as 4I. So, I'll substitute this as root of I plus root of 4I the whole square. So this will become root of I plus 2 root of I the whole square. So that is equals to 9I. Now, I minimum will be given as under root of I1 minus root of I2 the whole square. So this becomes root of I minus root of 4I the whole square, which is I. So the combination will be 9I and I. Option C. The next question. Two coherent monochromatic light beams of intensities 4I and 9I are superimposed. The maximum and minimum possibility intensities in the resulting beam. So again, maximum minimum intensities have been demanded. I would say I max for a coherent source is given as root of I1 plus root of I2 the whole square. So this is under root of 4I plus under root of 9I the whole square. So this is 4i plus 9i plus 2 into 6i. So that is I max is equals to 25i. Similarly, I minimum is equals to under root of I1 minus under root of I2 the whole square. So this is equals to under root of 4i minus under root of 9i the whole square. So this is 4i plus 9i minus 2 into 6i. So this is I minimum is equals to I. So 25i and I combination is D. The next question. For a wavelength 6000 angstrom unit, incident normally 7 fringes appear in thin film of air between 2 points. What is the difference of thickness between these 2 points? So difference of thickness has been demanded. I would say we can write 2 mu t cos r is equals to n lambda. We are all familiar with this formula. So this is 2 into 1 into t cos 0 is equals to 7 into 6000 into 10 raised to minus 10. So therefore cos 0 is 1 to the 2 t. So t is equals to 7 into 6000 upon 2 into 10 raised to minus 10. So this gives me 3000 times. So this becomes 21,000 to 10 raised to minus 10. But this is 2.1 into 10 raised to minus 6 meters. So this is option B. The next problem. In the next problem, we can say in Young's double slit experiment, if the width of the fourth bright fringe is 2 into 10 raised to minus 2 centimeters, then the width of the sixth bright fringe width of the sixth bright fringe will be. So fourth bright fringe width has been given and sixth bright fringe width has been demanded. But if we know that the fringe width, your fringe width is independent of order of fringe, it's independent of order of fringe. Therefore we can say that the answer will remain the same as 2 into 10 raised to minus 2. Option C.